Sorry, yeah, great.
No.
So I'll often introduce myself as Geneviève, but Geneviève is also very correct.
Geneviève. Yeah, actually, that's actually much more easier, Geneviève. Yeah, and yeah, we are almost
and I'm so sorry, my baby is waking up and he's crying in the background. So if you could give me a second, I can give him something to eat.
Go ahead. Yeah,
okay,
go ahead.
I'll be right back. Just one sec.
Okay, sure. Hello and welcome everyone to whoever's listening to this podcast on YouTube, Apple Podcasts, Google Podcasts, or Spotify, or any other platforms that you use. I am Shah. I invite machine learning engineers, researchers, and entrepreneurs to talk more about their current work, insights, and their journey on getting started with it. And for this podcast, we have with us Dr. Geneviève Patterson. She's the head of applied research at VSCO. Prior to that, she was the CTO of a video editing company that she co-founded with her friend called Trash, which was later acquired by VSCO itself. She holds a PhD in computer science from Brown University with a focus of research in video understanding. She was also a postdoctoral researcher at Microsoft Research, where she worked on interpreting deep neural networks and much more that I guess I'll be learning today with her on this podcast. So thank you, Geneviève. Welcome to this podcast and thanks for being here.
My pleasure. I'm excited about it.
All right. So to get started, can you tell us, I don't have a much more luck of talking to a lot of head of research people. So can you tell us a bit about what kind of research projects you are working on as the head of applied research at VSCO?
Right. So my startup, Trash, was acquired 2 months ago now. And so I'm still kind of in my first 90 days trying to learn a lot about my new team, my new company. And we're under 100 employees. So our research group is much smaller than Microsoft Research, where I worked before, where research is very similar to academic research. That researchers don't necessarily have to go to the NSF for grant money, but they're building projects based on how much impact they think they're going to have to the field. Often in industrial research, the goal is a long-term contribution to the company. So having some kind of application that is close to the company's business model is good, but really they're very academic. And my research is much closer to a user. So because we're such a small company, my research projects and what kind of academic research I'd like to implement or extend is always user focused. Can I see a user actually using this research in the next 6 months? Can I release it today? What is an approximation? This is a question that I ask myself all the time. If I see a cool paper, what is an approximation of the approach that they're trying that'll enable me to deliver this to a user as fast as possible? And that's pretty much how I came up with my last startup. And my projects at VSCO are similar, where I'm trying to think, what are techniques from model interpretability or model explainability where I can deliver some information to the user as fast as possible? What are techniques from video summarization or computational photography techniques that I can take a version of them that is less computationally intensive and put it directly into the app? So my day is usually 50 or 60% meetings with individual contributors, either in app developers or server-side developers, and saying, what are the workflows that you work on every day? What are the components of the product that you're working on regularly? And how could we take some approximated version of a neural network technique and apply that directly to your work, either making it easy for the engineer or making a more interesting output for the user.
Wow, that's really interesting. But if you were to take a step back for people who might want to learn about your background, so you did your undergrad in EEE and mathematics from University of Arizona, which by the way is an ASU rivalry. So people who would be watching these podcasts and who are Arizona State University students, I guess they might be dropping out of the call for right now, but just kidding. But definitely you did your undergrad over there from University of Arizona, and then you went for your masters in Tokyo. So trying to learn more about, I assume that would be the time that you first dabbled around your machine learning projects, or even the basics of machine learning. So can you look back onto those time, and can you tell us what was the first time that you learned about machine learning, and what was the thing that really interested you about that, hey, I want to explore more, and rather than not, maybe let's do a research in this particular domain?
Yeah. So I also grew up in Arizona, so like the ASU UVA rivalry is very real, like very. But it turns out once you leave Arizona, no one knows what you're talking about. And but I really felt like my undergraduate career, it was at a large state university, um, where I felt like I learned a lot about a lot of different engineering disciplines. So the idea of seeing problems from the user perspective is something that I gained while I was an undergrad, but I wasn't really introduced to machine learning approaches until my master's degree, where again I learned about machine learning from that perspective of the applied domain. And the first time I remember actually using a machine learning technique was in order to uh, classify the state of train platforms that I worked. So I worked on electrical machines and signal processing, like controlling motors and braking systems, and so I worked in a lab that had a lot to do with train systems. And they had this problem brought to them by I think it was the Kyoto subway and JR East Japan East Railways. Um, where they'd have this problem where trains would be off schedule. There'd be some accident or some natural disaster or something that would knock the trains off schedule. And they had lots of procedural techniques for figuring out what the recovery schedule should be in order to optimize for returning to schedule as quickly as possible. That seems like that's what you want to do. The trains are off schedule, you want to get back on schedule as soon as possible. Okay, problem simple. But it wasn't that simple in densely populated urban environments, because if you did that scenario as the subway system and these commuter train systems would do, the train platform would become overpopulated, and there would be more accidents or more delays because there'd be so many people that they couldn't stand on the platform, they couldn't get on and off the train easily. And so these different train operators came to the lab worked in and said, give us some more options. Sorry, my headphones
Oh,
have decided to turn off. I'm sorry.
yeah, I thought something went wrong around my end or so.
Headphones, unfortunately.
Oops.
Oh, there we go.
Yeah.
Okay. Right. So what happened was they wanted instead to say, how can we decide on a train schedule that is going to optimize from the person's point of view? How are we going to make it seem to the commuter like the platform is emptying quickly, getting on the train and getting off the train is the same way that it was when the train was on schedule? And so even if it takes a lot longer to recover the good train schedule, that from the user's perspective, that it'll be as comfortable as possible. And so we were trying to classify the state of the platform. Is it full? Is it moving? Are the people moving correctly on it? And so that was the first time that I saw SVMs trying to like look at a picture of a train platform and decide, are there too many people here? And is this train too full? And I thought that was kind of magical, and that the effect of it was kind of magical. And then the fact that the actual math involved was so understandable. Like, and it's funny, and I think that in general, machine learning has something that sort of defies understanding, like the high dimensionality of many machine learning problems. has a lot of unintuitive consequences. But the basic idea of, you know, a linear approximation to some nonlinear manifold, like that made so much sense to me. Okay, I'm going to be like a fortune teller, and I'm just going to linearly project my idea into the future, and then I'm going to know what it is. That seemed both magical and really understandable at the same time, and that's why I kind of changed my emphasis, and I went into machine learning.
Wow. I guess, to be honest, you would be the first person who might have said all the math behind these models was something understandable, and that made you interested into machine learning. I guess you are one of the rare people who are the genuine machine learning experts who claim to be having a love for machine learning, because most of the people, and I guess I can be included in that criteria, that my mathematics is not something I enjoy, but definitely I can dabble around if needed, but only if needed and when needed. That is the part that I try to understand. But yeah, that's really interesting. And to probe you more on that, just few facts about those projects. Like, was that something part of your thesis, or was that something part of your external work that you did, or like, because I assume, because for me, when I got started into machine learning, I just frequently went on the open source data sets.
Mm-hmm.
So I would always find out few people who might have done few things or not. But I guess I assume this was much more real world project where you were trying to solve something for someone as a part of your maybe coursework or something. So you didn't have anyone who would have published their model out there that, hey, if you do wrong, at least you have a baseline to compare. So was that part of your coursework, or was that something your own
No,
curiosity?
it was really the lab that I worked in was very collaborative, and so it was two of my lab members who were working on this project, and I was just interested in it, and so I helped them check their math, run their models, edit their paper. I was not a co-author, but I was just kind of like learning from them. I was like apprenticed to them voluntarily, and
Right.
you know, in general, that's something that it's quite difficult to find. It's not something that's like always an option. But when you're looking for a place to study, when somebody's looking for a place to study, I would always encourage them to look at the other grad students in the lab. That I think that definitely my idea of how grad school is going to go, and I think a lot of people's idea is that you're going to be apprenticed to this, you know, amazing, brilliant person, which you are, but that you'll have a lot of face time with them, and you will not. And so if you pick instead the grad students that you think you're going to work with, that can often lead to I think a lot of success, because those are the people that you're really going to spend the most time with. So school, and I happened to pick Brown University over some other places because I thought that my colleagues would be people I could learn a lot from and that I would enjoy working with. And when I went to Todai, the University of Tokyo, I also felt like that was a lab where I could work with the other people there very well, and they could teach me a lot. And yeah, and so that's how it went. And kind of this the thing you were saying before about like the mathematics being hard or easy. It's I didn't win a gold medal at the mathematics Olympiad. I'm not pretending that I'm a great theorist. But if you in that first problem that I had, and often in the problems that I'm looking at now, you don't have to demonstrate mathematical novelty. And if you can take yourself away from that super high and brutal bar, really, of innovation and novelty, and you can just think, "Ooh, this is a great tool, and I have a problem this tool is going to solve," then it can feel like a lot more fun.
Yeah, definitely. I guess your background in mathematics was the thing that resonated with you the most. Like, you were most excited about a problem from a mathematics perspective, versus me
Yeah.
when I have to design the codes in a distributed sense. That's what really excites me. That, hey, now I have a deep learning model. How can I make it much more efficient versus like making parameter efficient? So I guess it's the background that resonated with you the most.
Mhm.
But talking about extra projects, can you speak to more about what kind of efforts efforts that you did apart from your coursework or whatever was expected out of you as a graduate student that really made you interested in machine learning? Because I assume you are a person, you are a much more, it seems you are much more of a self-started person. So was there something that you did that not a lot of people would do, so as a advice to people who might be interested into getting started and taking the extra mile?
Yeah, so that is a good question, because a lot of people feel like, I have so much enthusiasm, and how do I apply it? And something that's just very difficult about graduate school, about machine learning, about research, period, is having to be your own supervisor, and having to direct yourself, and because you have like so little, honestly, so little feedback, right? You're working on things, but can you regularly pat yourself on the back and say, good job, you made your progress? That I think that that's very hard, and that's probably the most challenging thing about getting a PhD. um,
Mhm.
and so as far as like projects that I worked on, that and everyone will tell you this, that I tried very hard to pick projects that were publishable, and that was not always successful. That was, but it turns out that's fine. That I picked a lot of projects that, even if they didn't turn into conference or journal publications, ended up being workshop publications. Workshops, of course, have a different standard for entry. They're usually, interest based. They don't have the same review standards, um, but they're very valuable in getting feedback on your work, in feeling like you made progress, in making connections, in having, in a different world, and having a reason to travel. um, so I During my master's degree, I did this, several times in electrical engineering, and then during my PhD, I did this a lot, where I would think of, I would read an enormous amount of the literature. I would find some project that resonated with me, the way that you were talking before about different parts of our backgrounds resonating with us. It doesn't matter exactly what the topic is, but something that resonates with you, and possibly something that piques the interest of your advisor because they're paying you. And and then just thinking up a workshop paper level thing. Don't think that it has to be published. Like, don't think of the huge mountain that you might have to, you know, surmount in order to get something in a conference or in a journal. Just workshop, identify. And I often did this, where I would go through the workshops at NeurIPS, at CVPR, at Chi, and think, is this a workshop where I like the other people who are publishing there? I like the papers that are published, in the last year's workshop. And I would think, what could be something I could write that would end up in this workshop, and then work on like a workshop paper that's a couple of pages long. And that got me a lot of my conference publications. That the downside to doing workshop papers is that sometimes you lose momentum after you've done a workshop paper, and you don't actually finish it. So self-discipline, enthusiasm, those things are always difficult. But as far as an intermediate thing, I guess my big thing that was useful for me was trying to figure out what is a way for me to get feedback. Like, what's my own loss function? What's my own reward function? How do I feel like I've made some progress? And how do I feel like that pretty frequently? And that working on workshop papers was something that I thought was really good.
Hmm. Yeah, that's a pretty valuable advice. I mean, I can relate. I can borrow some of the advice right now, because I guess I'm in that very initial state. So yeah, definitely that's a valuable piece. And talking more about like your research work. So basically, it calls for PhD itself. So what were the factors that you considered? Because you had a much more I would say real based knowledge of machine learning. You worked on real data sets. So it could have been a very nice opportunity for you to go into the industry and say,
Mhm.
I have this XYZ amount of experience and I'm ready to work in the industry. Why did you consider, what were the factors that you considered for doing a PhD at that time?
Um, so the I didn't entirely choose it for myself. I finished my master's degree in the middle of a recession in the U.S.,
Wow.
and I uh, after my master's degree, which I did in a different country, which I would totally recommend to everyone. It's super fun. And the downside to doing a graduate degree that isn't in the place where you think that you're going to make your life is that it's a little bit harder to job hunt. The graduate programs really lead you directly into the next step of your career. And so you'll probably be living someplace near wherever it is that you got your graduate degree. And I decided after living in Japan for 2 years that I had an amazing time. It was such a fabulous part of my life, but that it was quite far away from my friends and my family. And I didn't think that I wanted to make a 20-year career in Japan. And so when I came back, it was difficult. Job hunting was difficult. And anyway, there weren't a lot of jobs. So that's why I went to grad school. and I'm really glad I did. I think that it turned out to, after another 6 years of graduate school, by the time I got to my postdoc, I felt like that was a good decision. That was the right decision. So,
But oh yeah, I'll like to probe you more on that. Last note is, can you talk to more about your PhD experience? Like what I guess you mentioned it pretty honestly that PhD doing a PhD wasn't your first plan, but it somehow was a part of your the circumstances you were in. I would rather say. So going into the PhD experience, and if you were to see in retrospect, what are the things that, apart from research, I mean, you have a stellar profile in research, so I won't be talking more about your research as of now, but talking about the non-technical traits, like was there something you can reflect back on through your PhD that you learned or you grew into that you might have something to speak to?
yeah, and I think that things like time management, self motivation, being able to make connections with people that you work with remotely. All of those things were really important to me. But I can't give you like really good advice about how I did it. It's something that in your own life, and also it's different for different disciplines. So it depends on what area of the world, what area of science you're in, exactly what skills are going to be the most important. The You asked for non-technical skills, and I think that the important thing that happened to me actually was that I needed many more technical skills than I thought I did. A lot of programming, honestly, like basic software engineering, is really, really useful and important for prototyping things, for producing things, regardless of your scientific discipline. That so much of any kind of science is massive data processing, doing some interaction with other humans, so creating some kind of UI, some kind of application, and that all of those things come down to software engineering. And the better a software engineer you are, the faster that you can prototype things. And I was reading a book by this science fiction author, Ursula Le Guin, who I really liked and I've liked since I was a kid. And it was like a kind of autobiography memoir. And she was saying that it's important to understand how to write sentences that sound good, that like those basic, very low level things about writing are really important to being able to write a really long novel. That kind of craft of understanding how to put together a sentence enables the bigger art of narrative storytelling. And I think that that's also true of science today, that the craft of software engineering and software development enables great scientific discovery. And so the thing that made my startup possible, the thing that made it possible for me to build the systems in my PhD that later led to me getting a postdoc, that all of those things came down to software engineering. And I didn't become a software engineer on purpose either. That was not the career that I wanted. That definitely wasn't the career that I wanted when I started grad school. I thought of myself as a scientist and learning fundamental truths and exploring mathematics. And I failed my qualification exams my first year as a PhD student in computer science. I failed them really badly. And, and so I had to take remedial. Well, it was remedial for me. I had to take undergraduate. I had to take the accelerated track of undergraduate software engineering at Brown. and it was really difficult. And then I had to take another very intensive software engineering exam. When I was at Brown, the exam was a 4-day programming exam where you had to do something like build Twitter or build Google Maps, like make it happen, 4 days, go, and do a version of it. And that was really grueling, but it made me enough of a better software engineer that it enabled the rest of my career. And I am not naturally a good software engineer. That very few things about software engineering make me really excited or interested, but it makes everything possible. So yeah, so you were asking for, I think a non-scientific thing that I would say is the most important thing is software engineering skills. So for myself, for my younger self, I would recommend building better software, reading about how to build better software, work on writing all of my software in a better way, and pushing myself to really write better software is a way to elevate, your later career and your ambitions.
Yeah, no, I really like the one point you made really stick into me was the learning the craft, and which is something I really appreciate because I have been reading a lot of blogs recently, and at least one of the blogs, I'm bad at recalling memories, but I don't know where I read this from, but I guess it was I was trying to learn what essentially contributes to a good PhD, because eventually you will work on projects, you will have publications, but what calls for a good PhD versus a bad PhD? And one thing that I learned was research is all about creativity, because you learn the implementations one way or the other, either you're in industry or in research, but it's all about how you apply it, how you apply it creatively. So I guess the one thing that really stick to me was the craft. So I'll definitely check out that book that you suggested. And yeah, to look back, yeah, definitely one thing that I think a takeaway from your answer would be implementation. That was something that you really become good at, and you became so good at that you went ahead to be a co-founder for a startup, which I guess I'll be asking more on those things later on. But while we are on the same note, can you speak to more about any of the drawbacks that you feel PhD had on you overall? I mean, I know this might be a personal question, so feel free to choose what you answer or not answer, but do you think that PhD had any drawbacks for you?
So it's been long enough now since I graduated. It's been 4 years since I graduated that I think the real pain of it is in my memory. But I know that when it happened, it was quite difficult for me to not pass my first qualification exam. That was hard. I don't know, it really bruised my ego and my image of myself. And self-direction is really hard. That my advisor gave me great high-level direction and introduced me to very interesting topic areas and helped me get internships that really built my career. But trying to decide what is a research schedule, coming up with my own thesis. And this was, so I also did faculty search before I decided to do a startup. And I think that this is what makes the difference between a good faculty candidate and a bad faculty candidate. And I was a very medium faculty candidate, so I would not pretend I have a great answer to this. But having a vision, a schedule for what your I don't know, passion, that sounds too kind of a weak way of saying it, but you're the captain of a ship, and what direction is your ship going in? What is your research plan? What is your vision? What is the coherent narrative of the projects that you're working on? How do they fit together? It's extremely hard to do that. And I found it very difficult to do that as a PhD. But as far as personal experiences in doing a PhD, it was not bad for me at all. I really enjoyed it. And I had some ego bruising during the process, but for me personally, it was not bad at all. And I think the difference between a PhD and a industrial job, a difference that I have experienced from having one, from being a boss of some people now for a little while, and from advising undergraduates and younger than me, graduate students, that I think your identity is really bound up in your PhD, and that's hard. For me, that was hard. That like who I am and how successful I am personally was so tied to my PhD. And that's not true necessarily when you have a job. Your job can suck, and that doesn't mean that you are bad in any way. But if you have a PhD and things are sucking at your PhD and in your research, you feel really bad about it. And if I could do it again, that I would try to separate that more in my head and really realize that those things are not related. Like you don't have to have a good PhD to be extremely successful. You don't have to have a good paper. One of the most famous computer vision researchers, Jitendra Malik, who's a computer vision professor at Berkeley and probably the most prolific creator of other professors in computer vision or computer science, did not have a single publication when he got his job at Berkeley. He just had a pretty interesting thesis, and the other faculty liked him. This is also truth about all jobs, that like you just need a champion. You need some people who think that you're cool. And so I know that this sounds very bad, but that like so much of your PhD comes down to luck. Like, did you happen to, run into the right collaborators? It is, I think that if you put together craft, being very good at programming, really like having some mathematical background that's stable, having a pretty good software engineering abilities, and having some luck or having enough patience to wait for the luck to come to you, that is a lot of it. And if things are going bad outside of those two things, it's probably fine. Don't feel bad about it at all. That would be my advice to myself, that like the great ideas and the sparkly, like exciting moments and products that I made, I didn't need to feel as bad about myself when these weren't happening. Like I could have relaxed a little bit and just waited for the good things to come. Yeah.
I didn't know the statistics about the Jitendra Malik profile.
Yeah.
It's definitely very encouraging. I mean, definitely I shouldn't be undermining him or his work back then, but definitely it feels encouraging. But before I move on to the technical aspects of your research, I just had one question: is how did you go on deciding your PhD topic? How did you and when did you decide that this is something I want to stick to for at least next 3 or 4 years, when I'll be building my expertise on? And how did you do that?
I did not do that. I don't think that my research plan ever extended more than a year in the future. So earlier I was talking about how a thing that I did in order to get into a new research area or to expand my capabilities in some subfield or on some topic was that I would try to identify a workshop paper that I could write. And then I would maybe be working on one workshop paper, 2 workshop papers, 1.5 workshop paper at a time. And one of them would be better than the other one. And that one would go to a workshop. And then if it was a strong workshop experience, that would develop into a conference publication. And if that was very good, it would develop into a journal publication after 2 years. But that's like already beyond the point. You already knew it was successful. And so it's easy to go, well, it's a lot of work, but it's not psychologically stressful to do the later journal publication. But I definitely thought about it more in that like 6 month to 1 year increment. And I know that is less possible in other sciences, that because of the time it takes to do experiments, the time horizon is longer. But at least in computer science, that 6 month cycle of inspiration, I think is useful, and it's useful to move forward. That can also feel a little punishing for publication schedules. It can feel like a lot of pressure to have to publish something every 6 months. But if you publish, a workshop paper and a conference paper every year, you will graduate in 4 years and be fantastically successful. If you do a workshop paper 1 year and a conference paper the next year, you will be pretty successful. That is what I ended up doing about that schedule.
Yeah, that's pretty.
And anyway, it turned out like Legos. Like you were wondering how did I think of my whole career, that it ended up nicely building on itself, kind of like little Legos that snapped together. That I had a workshop paper and then a conference paper, and then that inspired the next thing. And so looking back on it, it was easy to make a narrative because they all grew out of each other. Hold on a sec. Let me. Is this okay,
Well,
background? I know it changes the background, so it might make the YouTube video a little unusual, but
can you talk to more briefly about your PhD work? Like most of your PhD thesis seems to be revolving around video scene understanding. That's what that's what, according to my homework that I did, felt like. But I guess it could be more than that. So can you briefly talk more about what were the research projects that you worked on, and what was its significance in terms of the research community?
sure. So uh, uh, the big points of my PhD kind of separately were attributes for images. So of course, we're all familiar with object recognition, attribute understanding and recognition, like what are ways that you could describe the contents of an image, both in scenes. How can you describe a scene? How can you describe a person? That was very interesting to me, because I was interested in a kind of more human, qualitative interaction experience. And so the other big part of my PhD was a human in the loop computer vision. So how can you employ tens of thousands of people to create data sets for you? How can you interact with a user who might want to recognize something that's hard to define specifically, like hard to define in words exactly, but easy to recognize in an image? How can you help them make classifiers? And so that kind of human in the loop interactive computer vision pipeline was something that I had success with in the HCI community, in the crowd work community. And then that also led me to collaborating with the creators of the Common Objects in Context dataset, which is a big benchmark for image segmentation.
Yeah.
And so I worked with them on the challenge for how to measure, whether or not classifiers do well on those tasks, and how do we understand the performance of a segmentation model. As you get closer and closer to perfect, it gets like a little bit more and more complicated to evaluate whether or not your classifier is doing a good job. So kind of overall, my PhD and my interest during that time, and continues to be, how to use machine learning. How can an individual person use machine learning to explore a large world of data? How can we take something that's like fundamentally not a human capability? How can we look at all of the pictures in the world? How can you see all of the pictures of all birds ever taken in North America in the last 40 years and be able to, find a bird that looks like the bird you're looking at, or understand, what makes this kind of sparrow different than that kind of wren? How can we do these things that are really computer-like? And what's real difference between human and computers is infinite memory and perfect recall. Humans don't have those things, but humans have zero-shot learning abilities and generalization abilities. So humans can do zero-shot learning or low-shot learning. You can tell a human, find something that's got 4 legs and stripes, and they'll find you zebras. And so how can we take human inspired actions and human advantages and computer advantages, infinite memory and perfect recall, and how can we put those two things together to help a human achieve their goals faster? And that's what turned into my interpretability work during my postdoc, and also into my startup, which was about how to make it so that video editing is easier, which is also a thing where you want a perfect recall over a lot of footage. And how can you, you obviously have a lot of experience editing video at this point. So you know that it can be quite tricky and time consuming.
Yeah.
So yeah, that's, I suppose that was a long rambling thing. I went from, my inspiration was human interaction and human use of AI, and that inspired a couple of application things in slightly different directions, and that led pretty conveniently into my startup.
Yeah, no, definitely. That's what I wanted to extend your thought on that too. I learned that you also worked on interpreting deep neural networks while your work as a postdoctoral fellow at Microsoft Research, and I have briefly. I mean, yeah, I can say briefly, I have been into this research field. I haven't done any actual research, but I have been reading a lot of literature on interpretability. And one thing that I realize is it's hardly subjective. There is not amount of substantive research that is already out there that says you have to follow these ABC rules in order to make your deep networks interpretable. So can you talk to more about? I learned that you had a very nice paper or article, I would say, DeepMiner, that you worked on, and I assume this was during your work at Microsoft Research. So can you talk, or in general, can you speak to more about interpretability and what has been your journey so far into it, and how you see interpretability?
Yeah, I think that it is a very important subfield because it's related to that other thing that inspired me during my PhD, which is how can humans use AI? And of course, like we live in a capitalist society, so how can we deliver to people who want to give you money something that you will pay money for? and and making AI usable is necessary to making it profitable or worth spending our time and our company's effort on developing. And so interpretability, I think, is still um, in an early enough time in the development of that subfield that exactly the problems that are solving are slightly undefined. And the paper that I worked on, DeepMiner, which I am working on a follow up of right now, actually, hoping to have that come out sometime this spring, was about how can we look at mammograms, a kind of medical image of women's breasts to see if they have breast cancer, and how could we use deep learning, which of course can do a near expert level of classification of the presence of cancerous cells in these mammograms. How could we use them to help doctors triage cases that require more attention or less attention? If you have a large medical system and having people actually manually review these scans, that's very expensive and time consuming. And while it's happening, someone's cancer could be getting worse. So how can we use AI to do some assisting work? How can we help make the doctor's job easier? Because just saying that there's cancer also doesn't solve the problem. You would still need a doctor to evaluate this mammogram to understand how do you treat it. So how can we make AI more useful to the doctor? That was really my inspiration. And I think that interpretability work in general is a little bit different than a lot of other deep learning work because the objective is not easy to define. You don't want to say,
Hmm.
oh, I need an AP score of zero 0.9 on this, multi-class object segmentation thing. Like that's very easy to define. Do you line up the outline of the person's face with the actual outline of the person's face? I mean, it's debatable how easy that is. There's some mathematical problems there, but seems like a pretty well-defined thing. Did you explain your mammogram classification sufficiently so that a doctor can do their job better? That is very poorly defined. And if you don't have a well-defined objective, it's very difficult to update any kind of model, much less a deep learning model, which is almost expressly the whole reason they work is if you have very well-defined losses and objectives. Um,
Yeah.
so I think that like making the objective more clearly defined is a problem in interpretability, and I think it's just the fundamental problem of interpretability. How do we change our loss functions? How do we change our definition of a goal for a neural network in order to accomplish new kinds of jobs? And that I think a lot of things that are coming out of that field are sort of best practices, like best practices for the world, for how to do it in you work for a hospital, somebody works for a military organization or a law enforcement organization, someone works for a medical company that reviews pathology tests, all of these different kinds of places, um, that what are best practices for them to use in their actual day-to-day work, that I think that interpretability actually lines up a lot more with sociology research. research about governments and policy and how you should organize an institution right now than it does directly with uh, more canonical machine learning work because those objectives are so hard to define. So, like, if I was starting my PhD over, that's where I would really find a lot of interest. How can I set an interpretability objective that is really well defined? What does it mean to be well defined? How do you evaluate the success of your model against? I think that a lot of interpretability work doesn't have very good baselines. Like, what is a
Oh,
baseline? What's the benchmark in interpretability? How do you define a benchmark? If someone wanted to have a paper that was cited a lot, it would be developing a benchmark for interpretability. What does that even mean? And that,
yeah.
yeah, that's probably what I think is like a problem facing that field. That evaluation of utility is quite difficult, but that just means that we should work on it, not that
Yeah,
not that it should be ignored. It's a real, very real, and very valuable problem.
yeah, definitely. It feels relieving because that was something that I even found out, but I thought it was just me who is bad at doing literature review about these techniques. But it feels relieving that even people like you have found out the same things. But if I were to take a recap for interpretability, as we discussed, we don't have a very clear objective for any set of problems. We don't have a metric to evaluate. We don't have any benchmarks to compare, and versus we don't know how users would be interacting with the model, or versus how the data subjects itself, they could be also interactive within the model. According to your experience, do you think that the research in this particular domain is headed towards interpretability in deep learning, as that we are discussing right now, is like achieving these things? Because frankly, I don't know, I guess some of the organizations might be doing it, but the research is much more confidential to that. But at least the papers coming out don't try to be much more open. Like they are much more focused on the problem, that if, let's say, I'm working on Alzheimer's data set, I would make model interpretable for Alzheimer's, but that doesn't mean it won't mean that it would be interpretable on pneumonia data set, versus let alone like any kind of other video data sets. So do you see, or have you seen any kind of substantive research being done into this umbrella of interpretability? And if not,
Um,
what do you sorry for the long question, but like
no.
what according to you is limiting it? Is it just pure science that is limiting it, or is it something else?
So um, I think that exactly what you said at the top, like, what is a metric? What is a benchmark? What are we iterating towards? That our field, machine learning, is really set up to improve in that pattern. How did deep learning become relevant in the world? It has been a field, a subfield of machine learning for decades and decades. When did it become really popular as a research topic? In uh, 2012, when AlexNet had such excellent performance on ImageNet. So really, what happened was there was a benchmark with a very well-defined objective. It happened to also be large enough that you could show off the advantages of having a trainable model. So that's a secondary thing. But the year before AlexNet came out, Jan LeCun had a paper in CVPR for self-driving that was a segmentation of a cityscape using a deep learning method that was rejected because the reviewers did not believe that the results were real. And Jan LeCun wrote a Facebook post that said, CVPR is a horrible place. I will never publish there again. Nobody knows what they're talking about. So I think like your questions about like, where is interpretability going? What does it even mean? It's very difficult to review papers about interpretability because the field that they're applied to are so disparate. So what do I know about particularly Alzheimer's research or any other particular thing? It's very difficult for me to review that. I've maybe done a little bit of medical work on the specific task of uh, breast cancer, either pathology, cell slides or mammograms, but I don't know anything else about medicine. So how am I possibly going to review some other paper that's also on some specific subfield? So it makes it very difficult for reviewing. And it makes it difficult to say that you're building on someone else's research because, of course, we want domain applicable solutions. That really makes a difference in the real world. But it's difficult to build on someone else's toolkit if it's so specific to just one problem. And it isn't kind of designed with reusability in mind. So I do think that trying to understand what do we mean by interpretability. And it doesn't have to be a total solution, but a version of the question of what does interpretability mean? What are we trying to get with that? Having a metric that can quantitatively evaluate it, I think that that's very important. And one place I think that that's really happening is in natural language research, trying to identify is an embedding space, image captioning is an example, like is an embedding space showing why a translation is happening? Is it explaining why it's answering a visual question in a particular way? Is it explaining how a caption happened? That those data sets seem very much like toy data sets, but they have a quantifiable metric. So I think, yeah, and also that naturally research that has to do with words is good for the topic of explaining, because explaining involves words. Like there's some things that are just, the natural artifacts of the problem. But yeah, the broader point of like exactly where we're going with this, I think that will, emerge in the future years of how do we make a quantifiable progress in interpretability. And in some cases, I worry that only large companies can do that because they have access to the most data, and that these problems end up having to have a lot of engineers working on them because they have to interact with a lot of different kinds of data, which is difficult.
Yeah.
But yeah, I think like, again, starting out my PhD, if I could identify a data set, identify a metric, identify a benchmark, show that I validated or invalidated my hypothesis on a benchmark, and submit a paper like that, I think that that's a way to get cited a lot by a lot of people.
Yeah, no, I guess that I could take a shot at that, because that's what I'm trying to do, because I find myself much more blindfolded on those things. But yeah, I guess as you mentioned, even I guess the second inspiration for after Jitendra Malik would be like Jan LeCun for me. I guess if his paper was something that got rejected, it's something to look on to.
And I wouldn't I don't know that this is something that Jan LeCun would say that he came from, but you taking something that I feel like I didn't do. There's a couple of examples in my own PhD history that I felt like there was a problem that sort of bothered me. There was some evaluation of an objective or an organization of a deep network that like kind of bothered me that it was happening in a particular way, but I just let it bother me and I kept plowing ahead on whatever problem I was plowing ahead on. If it's bothering you, it's probably bothering a lot of people. So if you work on it, it's going to be appreciated by a lot of people too. If there's something, and not, a lot of people would give the advice of like not focusing too much on trying to compare to recent literature. I review a lot of papers. I review probably, somewhere between 6 and 10 papers for every top tier machine learning and computer vision conference, because there are a lot of papers submitted and they need a lot of reviewers.
Yeah.
So I do a lot of reviewing. And I would say that I am very frequently really drawn to papers who say, I'm not going to try to compare to absolutely every paper in the literature. I'm just going to say, this is a problem that I see, and I'm going to take a first principles approach to it. I'm going to say, what would I do logically? I'm just going to step through it like logically, like you would in a high school math class. I'm going to put one foot in front of the other, and they just keep doing that. And by the end of the paper, they have observed something interesting. And I find those papers, I am very likely to accept those papers.
Yeah, definitely. It cites back to the thing that we discussed previously, but was like creativity. It's all about creativity. We don't have to be purely technical always. It's like how to see in a different sense how we can be much more crafty about developing solutions rather than being technical. So yeah, definitely.
Yeah, and I think that really, having having like some fundamental skills, like you have, fundamental, totally within any grad school, any grad student in computer sciences wheelhouse, that they have like some fundamental mathematical skills, some fundamental programming skills. And if they say, I am just going to use these tools to, yeah, explore a problem on my own, and I'm not going to look too much at how other people are doing it, that I think I have in my own life been quite surprised at the quality of output when I tried not exactly to look at what other people were doing, and I just trusted myself to make it to the end of the exercise.
Hmm. Yeah, that's a valuable advice. At least I'll take that for sure. But trying to
It'll be worth a workshop paper for sure, and it might be worth a conference paper. So
hopefully, yeah, definitely. I guess I won't be overestimating myself for sure, but I'll try to do that. But trying to segue a bit out of interpretability, because one of the few things about your profile that I really liked was you plunged yourself into the startup space, which was you co-founded a startup called Trash, right? I guess I correct me if I'm wrong, but you did that after your postdoctoral position at Microsoft Research, and you went on to uh, developing this idea into a product, which was later acquired by a company, VSCO, which you are working at right now. So can you talk? I guess I can find out few articles which say what the tool is about and what VSCO does. Lot of people do already know what VSCO is about, but I want to learn more about the time phase when you came up with the idea and how you went on to at least thinking about that. Hey, this is what I want to nurture this idea into a product, and maybe like even if it wasn't acquired by VSCO, that would be a standalone company itself right now. So what was that time phase like? How did you go on to having the idea, to at least thinking that I want to be much more professional about it, and I want to build a product that I can make it profitable out of it?
so there is this guy who works at Square, I guess he works now, and he's his Twitter handle is Patio11,
Mhm.
and I can't remember what his actual name is, but anyway, he's like pretty successful entrepreneur. He's very well respected software developer, and he's always saying that there are so many companies making like $10 million a year, $100 million a year, and you never hear about them. And they're never like massively celebrated except, by themselves, and they throw themselves parties and stuff. But they're not like, they don't get this uh, 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 media attention or research attention or even like Twitter level of attention. People are just kind of out there doing their jobs. And the thing is that they're very successful. There's like so many ways to success and stability and usefulness and connection with customers and connection with people. There's a lot of ways. And we don't have to say like either an Elon Musk or I'm nothing. Like there's so many other ways to be successful. So yeah.
Yeah. I guess it relates to the thing that when we say I'm an overnight success, but it took me almost 30 years to be an overnight success. It's
Mm-hmm.
somewhere
Mm-hmm.
along those lines. So
Yeah.
yeah, I guess you were
Lovely.
referring to Patrick McKenzie. He
Yeah.
works for Stripe. Yeah,
I'm
yeah.
striped. Yeah, sorry, I confused Stripe and Square. They're very different. But yeah, and I started following him for advice about how to organize my startup when I started Trash. That he had like some, how to do staffing, how to organize your engineering team, and um, yeah, and it made me think like, wow, there's so many people who are good at this. There are so many ways to be good at this, and I thought that I was like totally crazy for doing a startup. I was like a little bit crazy, but I definitely thought that I was like doing a kind of ridiculous, hopeful mission in making a startup, and it's possible. It's just a totally possible and normal thing for you to do, and people should try it if they feel like it. Yeah. Right. So I think that I first wanted to start a startup when I was a master's student, right when I started my master's degree. So I've been thinking about how to build a business. What is a good idea for building a business? I was probably thinking about that for 10 years before I did it. And I was uh, always on the lookout for a good idea. I interned at a computer vision startup called Clarify, which is a run by a really brilliant computer vision researcher called Matt Zeeler, and has very interesting business plan. But I, for myself, was always looking at computer vision ideas, opportunities in the market, and trying to say, is that the business that I want to build? And I mentioned Clarify because they run a computer vision API, a recognition API. And I think that is a totally monetizable thing to come out of computer vision. But I didn't particularly want to build a SaaS business. And the business artifacts of that seemed quite difficult to me, like competing with some other large companies, Google, etc., who could also provide computer vision APIs, Amazon, Microsoft. That was like very intimidating to me. And when I was a master's student, and I was thinking, what kind of at that time I was thinking like electrical engineering sort of startups, that they were hardware startups that would be very capital intensive, and it would take a long time to turn a profit. So I suppose what I'm trying to get to is that it wasn't that I suddenly had an idea and I was like, oh, this is going to be monetizable, I'm going to turn this into a business. It was more like I was thinking, I want to have a business. Is this a good business? Is this a good business? Is this a good business for about 10 years? And I was introduced to my business partner, Hannah Donovan, by a mutual friend of ours that worked at Microsoft Research. And Hannah said, people are making a lot of video online. TikTok is a big thing. Musical.ly before it was a big thing. And video is very difficult to work with. And it's additionally very difficult to work with on your phone. So tell me some computer vision magic that you can do to help me, essentially auto-populate a rough draft of a video composition. And I thought, oh, that is something that is quite easy for me to do. I can prototype it for you very quickly. And I think that the part that mostly made up my app, the Trash app, which did exactly what I said, you select some videos, you select 10 videos from your camera roll, it picks out moments that it thinks are particularly attractive and interesting, it sets them to a beat of music, it cuts in your voice when it's appropriate, and it created for you this rough draft of the video that you could then go in and edit, exactly to your personal taste. That I thought, oh, I can do that very quickly. And the biggest parts of it, I probably wrote in a couple of months. The machine learning parts, collection of data, training of our own models, prototyping, probably altogether took a couple of months, and then it took a few more months to make the iOS app. And so seeing that line up took 10 years of thinking, what are elements of computer vision that are mature, that could make it into a product, trying to do other computer vision startups, making my own web app, different web apps, different large distributed computer vision training systems during my PhD, that I ran into things that I'm like, this is too difficult to commercialize. This is going to be too difficult to commercialize. This is going to be too competitive. This is going to be too capital intensive. This is going to require too large a staff. And then finally I ran into a thing where I was like, oh, I can definitely do that on my own. And it's only going to take me a couple of months and we can have a product out the door. And that's why I did. So that is one of the reasons why I did what I did. I also thought it was a fun idea. So it sparked my joy, and I thought it would be not too hard. And it was pretty hard, but it was the easiest of all the things I could have done. So yeah.
Wow. So I guess the key takeaway would be like you were intrinsically motivated by the application of what the Trash app does, and hence everything, like it's like again, I don't know why I'm bad today of recalling my memory, but I read this somewhere in the book. I guess it's an autobiography, or I don't know if it's a self-help book, where it says like figure out the whys and you will figure out the hows. So it's like if you're really motivated, why you want to do it, the rest of the things are just a matter of time depending on the thing that you are doing. So yeah, that's really interesting. But I guess my next question to that as a follow-up was like like at least for me right now, even if I'm just developing deep learning models, it's a huge task to at least implement those scripts that I write and deep learning models that I build, and getting on task. Like after that it's done, it's just a matter of tweaking those things, but it's a tough task. But I guess you mentioned you set up the whole pipeline for this particular trash app in just 2 months. But my question was like, uh, how did you go on to build an application? Because not a lot of people understand that doing research is like just one standalone code. It works on one data set, but compared to that, making an application that users might be interacting with it, where the reliability and robustness and real timeness comes into the play, it's a whole different domain, whole different expertise. But can you talk to more like how did you build that expertise? Because I assume by the end of when the trash was acquired by VSCO, it was a standalone app, and I saw it was available on all the app stores. So how did you was that something that you grew into again? Because I can take a
Yeah.
pattern out of your life is like you grew into a lot of things that were not in your first priority. So how did you do it, and what is something that people that you learned that people might not learn if they are not into that particular business?
So my app, when I first released it, was super buggy and crashed a lot. And it was a little bit difficult to use. It was not just a little; it was kind of difficult to use. But at that time, I felt like release it because I had a certain number of investors and they were expecting us to try to release it and see if people liked it. And I think that I even waited a little bit too long to release it. That I The stability of my app after it had been released for about a year and a half was possible because we had two very excellent iOS developers that we had hired. And so really like high quality comes from having a team and having, this goes back to my idea of if you want to be successful in a graduate lab, look at the other graduate students that you're going to work with and think who would be good coworkers. That a high quality product will be made by a team that works well together, but that doesn't happen on day one. And that's not a thing that you're like, oh, you know what, all I need to do is find the perfect coworkers and then the perfect product will fall out of it. It's more about doing things really badly for a while. That how Why was I able to make the deep learning models that ran on device very quickly? Because I had been building when I joined grad school, I built thousands and thousands of SVMs, and then I had a lot of neural network models. I had gone through many neural network training pipelines. I had built other web apps. I had like been building kind of bad things for 8 years before I started my startup. So this goes back to like being a good software engineer. That when you can really write something very excellent. It exactly addresses your problem. It's simple, it's elegant. It is because you have already written something many times that sucked. And and you don't see any problem as a new problem. All problems are a version of other problems that you've solved. The company that I started, it wasn't that I thought video editing by itself is necessarily my passion. I do think that creativity and creative work product and art is something that I really like to do and make part of my work. But that wasn't like the problem that I felt like I had to solve. It was more like I had tried many problems for a very long time, and then I found a simple problem that was a version of earlier problems that I had solved, and I was able to. So your question about like how did I get make an app when app development is clearly a different sort of software engineering, that I had several times in my career had to change what kind of language I was programming in. I had to learn a new language. I had to learn a new paradigm. I was from graduate school pretty familiar with having to pick up a new skill quickly. And I think that that was actually very similar to my PhD. Learning how to be a full stack engineer, learning how to be an iOS developer, that was very much like, oh, you have to take optimization and write a workshop paper on an optimization topic this semester. Go for it. Like it's pretty similar. And with the differences that you have like a bunch of investors that are like, we want our money back if you don't do it. And nobody ever said it quite like that, but they put a lot of pressure on you. So the upskilling was a lot like learning new skills in a PhD and having to learn it by myself. But as far as trying to figure out like how to address a problem, or figuring out what was the right problem to solve. It was that I had for 8 years or longer been not doing it very well. And yeah, and then that's really, if I had to like recommend a PhD, like what is a big reason to do a PhD? And it's that you get a lot of experience trying things out because you want to try them out. But if you work for a company, it's directed by someone else. So like the breadth of things that you can try out, the different kinds of systems that you can try to build is quite limited. And it's very
Mm.
open as a PhD student. And so when you finally get to the end of the road, you will know how to do everything better than everyone else. Like getting a PhD is good because you really will be much more capable and able to up level or gain new skills in a way that someone who has worked for a company for a long time might not be able to do, or might be less familiar doing. So becoming a self-driven thought leader, I think, is like a big takeaway from your PhD, that you can really do things on your own. Yeah.
Yeah, I guess the last note really sticks to me again is exploring the breadth. I mean, I won't even claim that I have done that, but the sort of work that you tried to explore, at least you had the aim to explore. Because one thing that I'm always kind of like at the risk of saying that I'm afraid, I would say I don't like, because when people ask me that why didn't you take a SD job, is something that I'm just not interested. But I know deep down the line that at least I should have the skills. I mean, definitely it's not something that is required, but it is a part of your daily routine. Like I'm sure even right now at your job place, it's not something that you can go around and you can work your way around it. So it's like full stack skills are definitely something that's required one day or the other. So yeah, definitely I'll try to take this as a note to myself that at least I have 5 years ahead of my PhD. I should be at least capable enough to do that, if not at least learn those skills. So but
And I think that it's like super valuable after you graduate. Like if you are not interested in being faculty, even if you are, like this might also help in picking students if you become faculty, picking students that will be able to generate a lot of research. But having a deep understanding of the software development workflow, how do you put things together? How do different steps, or how do you learn about a new full stack component and what requirements there are? That's really important at being an executive in a company.
hmm,
That I know that my startup was acquired um, both for the technology that we developed, the app that I work for. VSCO is a very popular photo editing community, and they have some video editing, but they really want to move into the video editing space, which is why they acquired us. But they also wanted me to be a technical leader at the company, and
hmm.
having having a real understanding of what software development and engineering requires, that's important to leading a team.
Yeah, definitely. And if I were to extend that particular advice of yours, because I guess right now I had this question planned out for you, but I guess this question actually makes sense more now since I've learned a lot more about you. Is can you, like most of the people that even when they reach out to me, and even though I'm definitely I'm not an expert, but over my years of my journey into machine learning, I still fail to answer and give the best answer. And feel free to take a shot at you can take a shot at this. Is most of the people are interested in machine learning because of the coolness it brings, and which is nothing wrong in itself. I mean, a lot of people get into machine learning just because how cool it is, but they find it overwhelming. I mean, where to get started, even if that person is highly capable and skilled and talented, they find it much more overwhelmed by the kind of coursework or the resources, because definitely coursework is not something, not always designed to give you the best interest unless you are into one of those very nice schools. So what has over the time been a nice kind of a pipeline for you to learn these things? Let's say if I want to say to you that, hey, let's sit together and learn the state of art of NLP, what would be your pipeline looking like, and what did worked out the best for you, and how did you go on to learning things? That would be, and I know this answer wouldn't be specific to you because not every solution works for everyone. So can you shed some advice for young researchers?
Yeah, well, I think now more than ever, there is a crazy amount of possible information available online. There's just a flood. There's so much, and that can be so intimidating because there is so much. But even 10 years ago, when I was starting my grad program, um, I was thinking some teachers are better than others. Some courses are better than others. Some things are more understandable, and uh, so I really love the Justin Johnson, Andre Karpathy deep learning course at Stanford, the CS
Two.
132 or 123 or something. Anyway, I taught a version of that class at Tufts. I bootstrapped
Oh,
from their curriculum. I really love their curriculum. Um, and I really loved my advisor, James Hayes, taught a computational photography class at Brown, which is also available online with all the homeworks and stuff. It's in MATLAB, I think, but James Tompkins,
mhm.
current computational photography professor at Brown, I think has a version with Python skeleton code. And uh, I, I think doing any coursework is great. Doing a course that you enjoy more is important to finishing that course. So picking the one that like you will actually finish. And I took a couple of courses in optimization, in basis, in software development, which don't happen to be publicly available, but are quite challenging, and I enjoyed them. And so the even though I'm not an optimizations researcher, like the topics from that course, I can understand much better theoretical machine learning papers that use optimization techniques because I once took a course on that I was interested in. So early in your graduate career, it's very difficult to balance. Do you take more courses or do you do more research? And I don't have any advice on exactly how to divide your time, except that the time that I spent on courses was very useful. The time that I spent on publishing research was also very useful. So I don't know, get more time somehow in your life. But picking a couple of courses that you think are like really good, that you really enjoy. Don't worry that there's other courses out there that are better or there's more information that you know. You don't have to know everything. Knowing something really well, knowing some set of things really well is so valuable. Actually, this is going to sound a little trivial. I have an aunt who once told me that the way to become a great cook, she's like very good home cook, and she said just memorize 5 recipes. 5 recipes, and if you can do 5 recipes, then no one who comes to visit you will probably have the same thing twice, or if they do, maybe you'll like do a little variety on it, and they'll think that you're so amazing and you'll really only know how to make 5 things, but it'll seem like you're really great. And the thing is that once you learn, and in this last year I have been getting into baking, so I am learning this a little bit myself. If you really know how to do like 5 different kinds of, recipes or pastries, you learn so many fundamental techniques that you really do know a lot about a lot of other things, and so
Hmm.
you really quickly become an expert. So my the thing that worked best for me was taking like a curated set, a few courses that were very deep and probably quite difficult, but I really enjoyed them, and focusing on those. And then another thing on the side is reading a ton of papers, but don't try to read them too strongly. Like read 100 papers, but read them very quickly.
Hmm.
um,
Yeah.
don't worry about absolutely understanding everything, and that'll give you like a very high level knowledge of where information is, and then that brings you back to writing a workshop paper, which is you have some very high level skills that you got in a course, that you practiced in a course. You have some breadth of information because you read about 100 papers. Just do 100, like make it an exercise. That is what I did my first year of my PhD. I tried to read 100 papers by reading 2 papers a day, and yeah, and by the end of it, I really felt like I knew the object recognition and scene recognition research my first year. And then I was able to think of a workshop paper that I was like, this is the new thing that I'm going to do. And I tried to go about it from a first principles sort of way. And I wasn't always successful in all my papers having this like very clear line. But the very first paper I wrote in my PhD, that's how I did it. And I thought it was pretty successful.
Wow. Yeah. I mean, yeah, this is a valuable piece of advice, and your aunt's advice is definitely great. I mean, I never looked at that that way, but I guess that's what most of the people do. I mean, when they claim to be experts, I guess, I mean, not to undermine that they are experts in that field, but it's much more narrowing down your research and just being an expert into that, because it's practically impossible for one person to be a an expert in at least 10 topics, let's say. It's just going to be one or two. So yeah, narrowing down your
Yeah.
focus is
And then
something.
it really turns out that if you're an expert in any topic in computer science, it will be applicable to another area of computer science. So if you're an
Yeah.
expert in even like one very narrow thing, whatever techniques you use are almost certainly going to be useful in another area. And yeah, the read 100 papers thing was recommended to me by Spike Hughes, who wrote the famous graphics textbook, computer graphics textbook that is taught most undergraduate computer science curriculum, John Hughes, and he said that's just how you get on top of something, especially the first time that you're trying to get into a new topic. So early graduate students, it's like read read a ton. Yeah.
Yeah, yeah, and yeah, I don't want to extend that answer more, but I guess that's what one thing that resonated with me, because if you remember, I told like I want to get away of software development, and hence I got into research. But when I was talking before I enrolled myself into a PhD program, just so I know what I'm getting myself into, I talked to a few of the computer science PhD students who were about to graduate, and they said you can't get around software development. You will have to learn the one way or the other. I mean, it's part of your, it's kind of an hurdle. You are seeing that there are two branches, it's not just that. And I realized that in just maybe my first 6 months, when I was trying to set up my when I was trying to set up my deep learning model to work on my school's server, and I was just trying to do all those things. I was trying to learn how to set up my server into a distributed GPU server, how I can use TensorFlow. I mean, TensorFlow is much more
Mhm.
UI oriented, so it's not much task oriented. But yeah, I definitely second to that particular thought. And
Yeah, and having the ability, or even if it's not something that you're terribly, it's weird because I say, like, it's not something that terribly interested me, but my husband is a distributed systems professor, and so I get, like, the perspective from him of, like, why it's interesting, certain network configurations or exploring how to set things up in a distributed way, and when I hear about it from somebody who is very interested in it, and so maybe this is another recommendation, make friends in other areas of computer science, because they will tell you, like, what is the interesting perspective on that work, and that will help you get into it, and then definitely with software development, and also I think with some systems knowledge, you can just make so many more machine learning experiments. You can just set up a lot of experiments, and the more experiments you do, the more research and the more answers you have. Yeah. So
no, yeah, I mean, yeah, that was actually the thing. Like, I mean, just to get you more curious about this particular, what got me interested into distributed computing was I was running this. Like, there were few PhD students whose model that I was using who graduated a few years back in my lab, and I was using their models, and it was built for just one GPU. So what happened was, like, I had a 40 epoch system, and that 40 epochs would take around, I would say, 14 to 16 hours for total completion. And this was neuroimaging data, so it's like a very, like, I guess 12 GB of data that was being crunched at a time.
mhm.
And he didn't do an optimization for GPU, because at that time GPUs weren't available to our lab. And when GPUs were available to my lab, and when I learned that, hey, at least I should take a shot at this, and I had taken this what was the course name, distributed systems for machine learning. I had taken this course as a graduate student, and when I just did few basic code changes, and thanks to TensorFlow, I mean, it's super intuitive, and I was able to do those things in just at least less than half an hour. Like, the whole thing from 16 hours to now is reduced to maybe half an hour or maybe slightly more than that. So that alone got me interested that, hey, I should be exploring more about this. I mean, at the end, I should be knowing how to optimize my things. So yeah, yeah, definitely.
Yeah, I think that that's super super useful. Like uh, debugging time, something just in general about software development, about machine learning development, about all of these things. If you can shrink debugging time, that's going to make an enormous impact on your research and on your
Yeah.
quality of life. Um, but and I didn't make this work when I was a graduate student, but Andre Karpathy, whose course I mentioned earlier, like one of his big recommendations for graduate students is to work on blogs and work on their Twitter and work on their podcasting. And so if you think of like some accelerations like that, definitely like tweeting about them, sharing them in some way, that leads to jobs and speaking engagements and collaboration invitations. It can be really useful. So do it for yourself, do it for your friends. It will be really good. Yeah.
Yeah, definitely. And while we're on topic of exploring more than just machine learning in computer science and maybe trying to make a ride around the computer science umbrella, I have invited at least just maybe a handful of people who I have the privilege of asking this question. Is you have, if I were to look back onto your profile, you started off as a person who was into electrical engineering and mathematics. Later on, you transitioned to slightly research or maybe applied research. Then then at least the situations made you take a PhD. Then you got into pure research. Then you graduated with a stellar profile, and you did your hands around in startup, which is much more implementation level. And now you are head of research that is along the lines of product design and much more than just implementations. So you have your ride around computer science on at least most of the arenas that people might think of. But most of the people that I see and students targeting is just a job at Google, job at FANG companies. So what would be that one piece of advice that you would give for people in the direction of exploring more avenues in computer science? It's not just about getting a job that is highly paid or highly cited, but like exploring. How would you give an
Yeah.
advice on same note?
So I would, and I got this advice from another famous graphics professor at Brown, Andy Van Dam, who Andy, the cowboy in Toy Story was named after, because his students were all Pixar people. So somebody who really influenced research, and then also had lots of students who built fabulously successful companies. And I was asking him, how do I know if I want to go into business and do a startup and push technology forward from an industrial perspective, or sorry, my brain turned off for 1 second. How do I want to go in an industrial direction, or do I want to, continue to work in pure science? And he recommended doing an internship at a startup. And that is what I would really recommend to people who it's possible for. So something I think that I myself and my friends have been nervous about is, how do you get a steady paycheck? Like as a graduate student, maybe like your pay isn't so great, and so you're a little bit closer to that reality of making your rent. But I think that I was pleasantly surprised in my own life that startups pay a lot better than I thought they did. So finding a startup that has reasonable pay, and then doing an internship in a startup. If you're a graduate student, you have several years, so you can do a Microsoft startup, you can do a Google Microsoft internship or a Google internship. But you can also maybe take one summer to do a startup internship, and that gives you like a really good perspective on the type of work, and that whether or not you want like a certain kind of stable corporate experience with a lot of benefits, whether you want the excitement and the self-direction and really like the power to set your own life of doing a startup, or similarly, if you want the power to set your own life, but you're not as interested in interacting with consumers, to go into research, you really have the chance to do that in grad school. And so I would recommend trying to try them all out and see which one just seems the most exciting to you personally.
Yeah, no, that's a valuable thing, and that is one thing I have that as a to do for me. Like I want to work at a startup in the first few years after my PhD. I don't want to jump directly into a big company where I'll be working on a preset of implemented pipelines. I want to learn how I can actually build those pipelines, or at least see them building. So yeah, definitely. And yeah, we are
And
almost
I'm so
towards.
sorry, my baby is waking up and he's crying in the background, so I might have to let you go. If you could give me a second, I can give him
Yeah,
something to
go
eat
go
and I can
ahead,
come
go
back.
ahead. Yeah, go
Okay,
ahead,
I'll
go
be
ahead.
right back. Just one
Okay,
sec.
okay, sure.
Hi, I'm back.
we are almost towards the end of this particular podcast, and on a concluding note, I just have two questions. Is first being, what is one technology or idea that is being researched into the research community a lot that you are particularly trying out, or maybe you are just very optimistic about looking at those results? What is something that is you find that might be much more interesting to look at?
Sure. So uh, I think that transformer research using attention-based mechanisms for sequence modeling is exciting because it's such uh, it can end up being computationally more lightweight way to run a model, which is exciting to me, who runs models on phones all the time. And I think that it makes setting up joint embedding spaces a little more convenient. So I think that in a lot of media companies, really retrieval is an important thing. That's maybe a less robust area of research right now, but it's very applicable to consumer applications, being able to retrieve media or match things based on content, but not necessarily the same media type, text, images, users, user histories, videos, etc. And so yeah, transformers, joint embedding spaces, those things I think are exciting for rapid implementation. Yeah, in the consumer space.
Right, right. And yeah, just one last question would be, I recently found out while I was doing a homework about you is like you are involved at least by some bits, or like I don't know what exactly. I'll give the stage for you to talk more about is you're involved with something that has to do with AI for climate change. You're in the content committee. Can you talk to more about how exactly you are a part of it, and how exactly in general the space of using AI for climate change is being worked? I mean, not a lot of research is out there already where people say
Mhm.
how exactly AI is being used. It is being used for sure, but can you speak to that?
Sure. So I'm a volunteer with Climate Change AI, CCAI, which is an organization that grew out of the AI for Climate Change workshop at NIPS, another example of workshop being very useful. And the founders of that nonprofit organization wrote a paper which hasn't been published in a journal, but is being cited a lot, and I hope having influence in policy spheres and in applications. And so if you search for climate change AI, you'll find this paper, which is on arXiv, which has a list of climate change mitigations, like climate change is affecting the planet. This is a reality, and we only have three options: mitigation of the effect, adaptation to the climate change happening, or suffering. We can just deal with the bad thing that's going to happen. And so on a lot of mitigation and adaptation topics, using machine learning to recognize how to optimize our resources or how to adapt to changing world effects is a place where it's possible machine learning could be useful. And their paper has a lot of specific recommendations. What I'm doing is designing a course in the example of those courses that I said earlier that I really like, making some interactive Python-based course materials where people who work at companies that might have an effect on climate change can learn how to use some of these techniques so that they can introduce them directly into their products.
Yeah, definitely. I'll be the first person who would like to enroll myself in that course for sure. So yeah,
Well, I'll let
definitely.
you know when it comes out. You
Yeah.
can promote it for me.
Yeah, definitely, definitely. But yeah, that's the end of this podcast. I didn't have any much more questions in general for planned for you, so I'll like to thank you. I know this has been a long podcast than the previous one, and I guess that's one like previous to what I committed for you is like maybe a 1 hour thing. So thanks for bearing with me, and thanks for being patient about it. But this was one of the best podcasts that I had, because one of the reasons like you are being super honest about, and a lot of experiences that you shared was something very detailed. So I really like that, and I hope anybody who is listening or watching this video finds it useful. And I'll leave a couple of links to your social media profiles or any ways people can connect to you for your LinkedIn and your Twitter for sure. So, but thanks for being here and thanks for taking
My
out such a
pleasure.
long time. And
Yeah, my pleasure. Thanks for letting me go on and on. Yeah, I hope it was helpful. Thanks for having me.